center of mass. I'm guessing in the other video I must have just labeled it wrong. I went through equilibrium and turning effects or whatever. So, center of mass. Now, it's basically a definition and an idea. The center of mass is it's the point on an object on which all the mass appears to be coming from. So I typed it out. That's the rule from the textbook. Every object behaves as if its mass was concentrated. I think that should say were concentrated. It doesn't sound right. As if its mass were, yeah, that sounds better. Concentrated at one point. So we have this soda can. This is a fun little trick to do in the restaurant. That you have to drink most of it, but you drink it down, and then you get it to a point where you can tip it on its end because it's only about that much soda pop left in it. You know, and it'll actually balance, and that's because the center of mass is like right here. Most of the mass, it's acting as if it was concentrated at one point. You've done center of mass tricks with rulers. If you hold out a ruler and you put your finger underneath it at the right point, you can lift the entire ruler because it's as if all the weight was coming from that one spot. If you lift, let's say your ruler was on a table, right? If you lift this part of the ruler, you won't be lifting all of it because this part will still stay on the table. And if you lifted that part, you won't lift all of it because that'll stay. So the center of mass is that point where it seems as if all the mass of the object is at that one spot. Alright? So it's a really small topic, guys. If you want things to be stable, you put the center of mass low. It's the reason it's like a bulldog. You're not going to knock a bulldog over, but you are going to knock over, a bigger dog. And that's because, the bulldog's short and stocky, and all its weight and its mass is down low. Versus if I had a taller dog, if we were to push both of them, this guy would be more likely to fall. You see it in the lab all the time when you have your retort stands. There's a big heavy weight at the bottom, and then there's the pull so that you can, hang your test tubes off of without it falling over, and that's because its center of mass is low. If you really want to be safe when you set up your retort stand, you set it up so that your test tubes are hanging low, not high, where it's more likely that they'll tip over. Because when it's down low, your center of mass is around there, and when it's up high, your center of mass moves up. The higher the center of mass, the less stable the object is. Okay? Now to to determine the center of mass of a weird shaped object that's 2D, two-dimensional, so most likely a piece of paper. In this case, you've got a piece of card that's this weird shape. Alright? If it was a square, it'd be easy to work out the center of mass. You just use a ruler and you find the center. Put your finger there, you'll balance it. For an ob-shaped 2D object, you use something called a plumb line, and that's this right here that he's holding. Okay, and what it is, it's a piece of string attached to a weight, and that will always hang straight down. And that's actually pinned into the wall. And then what you do is he put a bunch of little holes in the corners of his piece of paper, and he will hang it against the plumb line, and then he will trace the plumb line onto his piece of paper over and over and over. And then you'll notice that they will all cross at a point, and if you put his finger on that point, it'll balance. Okay, so we use the plumb line method to work out this one. That's scientific jargon for a flat piece of paper. Describe qualitatively the effective position of center of mass on the stability of simple objects. Again, the lower the center of mass, the more stable. Think about it this way as well. If you had two of those buses in London that have, the double-decker buses, upstairs and downstairs, right? So you've got two of the world's worst drawn buses. Let's give it some wheels. Alright? If you put all the fat people on the bottom, so fat teeth apparently, alright, on bus A, and then on bus B you put all the fat people up top. How they got up there, because there's stairs, I don't know. What you now have are two different centers of mass. You can actually very clearly see it. On bus A, most of the weight is down here, center of mass. Can't tip that bad boy over. On this one, most of the weight is up here. So when that bus turns a corner and it starts to tilt a bit, ooh, how I do that? That one's going to fall over, and this one, it can't fall over. It's really close to the wheels. Okay, you understand the syllabus says describe qualitatively. So as long as you can say that the mass is close to the ground, therefore it's stable, you'll be fine. Things that also increase stability: a wide base. Scientific reason why the center of mass causes stability is because of moments. Okay, if these are your pivot points, let's say the bus tilted a bit because it was turning a corner, your pivot points are there. That's your distance, right? And your moment is F times D. If you have a large distance and the force will be the same, you're going to have a big moment, which means you're going to tip, versus this guy, same weight, so the same force, but your distance is a lot smaller. F times D, less moment, you don't turn. These guys, that's a huge moment when they hit that corner, so they're going to tip. We saw it yesterday at the non-mariners race. Someone's boat tipped over because everybody went to one side. So yeah, that's that one. Let's do, should I do separate videos? Yes, I will. So let's take a check. Done. Done. Stability, you want a wide base, and you want the center of mass to be low.